Now, sometimes when we're solving equations by taking roots, we'll end up taking a root of a fraction. How do we simplify a root of a fraction? Well, the first thing we might want to do is to split up the fraction so we have a root in the numerator and a root in the denominator. And we do that with this property of roots, which is the same property as this property of exponents. So sometimes that's enough to let us simplify our fraction. For example, if we want to simplify the third root of the fraction 10/27ths, we'll have the third root of 10 over the third root of 27, which is the third root of 10 over, we can actually take the third root of 27. That's 3. And notice that at this point we do not have a radical in the denominator. That's what we want to have happen when we simplify roots of fractions. We consider a quotient of radicals to be simplified when there are no radicals in the denominator. And the reason we want to have no radicals in the denominator will become clear later. For now, just keep in mind we want to have no radicals in the denominator. If we have a fraction with only one term in the denominator, making any radicals in the denominator go away is easy. We use a procedure called rationalizing the denominator because roots are typically irrational, so getting rid of them means getting to a point of having a rational number. And the procedure looks like this. We find the smallest number that we can multiply by whatever's inside our radical to get a perfect pth power. We can use a table on the calculator, we can do repeated division. We have lots of options here. Whatever that number is, so that a times b is a perfect pth power, we'll multiply the numerator and denominator by the pth root of that. Then we'll actually simplify the numerator and denominator. That'll involve taking the pth root of a times b, which is something we can do. So again, that procedure is complicated to say, it's easy to do. Suppose we want to simplify the fourth root of the fraction 7/8. Well, that's just the fourth root of 7 over the fourth root of 8. And we might try on the calculator and see if we're lucky. The fourth root of 8 is not an integer. So we're going to just try some perfect fourth powers, right? 1 to the fourth is 1. 8 is not a factor of 1. 2 to the fourth is 16. Oh, but 16 is 8 times 2. So I would like to be taking the fourth root of 16 in my denominator. To make that happen, I'm going to multiply my numerator and denominator both by the fourth root of 2. So I've got the fourth root of 7 over the fourth root of 8. And I'm going to multiply my numerator and denominator both by the fourth root of 2. In my numerator, when I combine those radicals, I'll have the fourth root of 14. In my denominator, I'll have the fourth root of 16. And the reason that that's good is that the fourth root of 16 is something I can do. My numerator, I'll leave the fourth root of 14 alone. In my denominator, I'll just have 2, which is pretty nice. So the fourth root of 7/8, that simplifies to the fourth root of 14 over 2. And again, when I say that those are equal, I really mean equal. If we throw this into the calculator, the fourth root of 7/8, that's about 0.967. And throwing fourth root of 14 over 2 into the calculator, I get that same awful decimal, which is about 0.967. So when we say those are equal, we really mean they represent the same number.